Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. If y equal to sine inverse of x, the whole divided by square root of 1 minus x square, show that 1 minus x square into y double dashed minus 3x y dashed minus y equal to 0, right? So your y double dashed is nothing but d by dx of dy by dx, and your y dashed is nothing but dy by dx, right? So like we've solved in many other problems in the past, this is a simple y equal to f of x, where your f of x has a sine inverse, and therefore it is okay to do a substitution and simplify y and then go about solving this particular problem, right? You arrive at y dashed, you arrive at y double dashed, and then put it back into the expression to showcase that it is equal to 0. That is one way of doing it, and there is no harm doing that, just that it might be a very long way to solve that particular problem, but definitely it is not wrong. So I'm going to try this particular problem without any substitution, directly from first principles of sine inverse of x and the quotient rule, or you can call it even the product rule here, because you've got a product of two functions, sine inverse of x into 1 by square root of 1 minus x square. That is one way of looking at it. The other way of looking at it, if you want to apply quotient rule, is you've got a function of the type f of x by g of x, where f of x equals sine inverse of x and g of x equals square root of 1 minus x square, right? So let's apply the quotient rule, and let's see what do we get for our y dash, right? So I'm going to write my y dash using the quotient rule. My quotient rule, when I apply, what do I get? I square the denominator first. This is what my quotient rule states. And when I square the denominator, what do I get? I get a 1 minus x square, right? And as we proceed, you will slowly understand why am I not doing this by the method of substitution, right? And then I retain my expression in the denominator, and then I differentiate my numerator with respect to x. And what is there in my numerator? Sine inverse of x, right? And what is d by dx of sine inverse of x? It is 1 by square root of 1 minus x square, right? 1 by square root of 1 minus x square. So this is our part 1 of the numerator. And then I have a minus of. Now I pick up my denominator, which is d by dx of square root of, let me write that and then we go to the next step, square root of 1 minus x square, right? And then I have to retain my first function, which is nothing but my sine inverse of x, right? So this is what I have. I apply the quotient rule. Now I'll move to the next step. Simplify my y dashed. My first part of the numerator is the square root of 1 minus x square into 1 by square root of 1 minus x square, right? So what does that become? That becomes 1, right? So that is 1. I write it as it is. And then I have my second part of the numerator, which is the sine inverse of x. I write it as it is. And then my d by dx of square root of 1 minus x square is nothing but, an application of the chain rule, where I will differentiate my outer function square root, and we know that d by dx of square root of x is 1 by 2 root x. So I'm going to write that first, and instead of x, what do I have here? I have 1 by 2 times square root of 1 minus x square, right? And then using the chain rule, I go into my function inside the square root, which I usually call the inner function, which is a 1 minus x square, right? And what is that? D by dx of my inner function is d by dx of 1 minus x square, which is a minus of 2x, right? The two out here highlighted in yellow, they get cancelled, and I can rewrite my y dash like this, right? 1 minus x times. So this is what I get, right? My 2 and 2, which I've highlighted in yellow, gets cancelled out, and I have a 1 minus sine inverse of x into minus xy square root of 1 minus x squared. So minus into minus becomes plus, and now what I have is 1 plus x times sine inverse of x divided by root of 1 minus x square, right? And you must be wondering, why do I actually bracket this particular expression, right? The reason I bracketed this expression is when we work out y dashed and we have the answer for y dash in front of us, I see that I have a possibility to express my answer in terms of y. Why is that? Because my sine inverse of x divided by root of 1 minus x square, which I'm going to highlight in green, is nothing but my y, right? So go back to the original problem. Your y is sine inverse of x divided by square root of 1 minus x square, right? So that is what I have here as well, right? So I can rewrite my y dash in terms of x and y. So basically, what am I actually doing? I'm converting an explicit function into an implicit function, is what I'm actually doing, right? So 1 plus xy divided by 1 minus x square is your y dash now, right? Now, what do? I try and connect this with what I've been given, right? See, look at this expression. Let me highlight it in a different color. I've been given 1 minus x square into y double dash minus 3xy dash minus y equal to 0. This is what I've been asked to prove, right? So I have my y dashed, and I notice that I have a 1 minus x square in the denominator of my expression which I have for y dashed, right? So what I do, I'll cross multiply and rewrite this expression as equal to 1 plus xy, right? So now you see we have an opportunity to do a next order derivative of this particular expression, right? When I do a next order derivative of this particular expression, I have an expression in terms of yx, y dashed, and y double dashed, right? Now let's apply the product rule. My first part, y dashed becomes y double dashed. I retain the second function as it is, which is my 1 minus x square. Now I retain my first function as it is, which is my y dashed, and I differentiate my second function, I get a minus 2xy, right? I do a equal to 1 becomes 0 because d by dx of 1 is 0, and then I have an xy, which is nothing but again an application of the product rule. So I get y dashed times x, right? Plus d by dx of x is nothing but 1, and then I retain the other function by means of product rule. Therefore, I have an expression which more or less resembles what I want to. I think we are almost there, right? So let us rearrange this particular expression. So y double dashed into 1 minus x square, I'll retain as it is because that seems to be a part of the expression what we have in the question. And then look at this. I have a minus 2x y dashed out here. Let me highlight it and say yellow. And then I have an xy dashed here, right? Let me highlight it in yellow as well. So these two expressions in yellow I can combine, right? So I moved xy dash to LHS, which means I will have a minus 3 times xy dashed, right? And now I also am left with a y, right? So I move it to LHS. So I have y double dashed into 1 minus x square minus 3xy dashed minus y equals 0, right? And let's go back to our question. Let's see what have been asked to prove. This is exactly what we've been asked to prove, right? And that is what we have arrived at. So let me highlight it in pink. I hope you like this video. Please do subscribe to my channel and support. Thank you.